This is Algebra 2, Lesson 6-2, Multiplying and Dividing Radical Expressions. In the last lesson, we learned a little bit about radical expressions and how to deal with the fact that if there's an odd index root, when you need to put in absolute values. Today we're going to look at multiplying and dividing radical expressions. Now, knowing your perfect square is greater than 1, for example, 4, 9, 16, 25, etc., will help you simplify some radical expressions. If you don't know your perfect squares, then you're going to have to simplify them by breaking them down by dividing by 2 or 3 or something of that nature. Now, you can simplify a radical expression when the exponent of one factor of the radical is a multiple of the radical's index. For example, you can simplify the product of powers that have the same exponent. Similarly, you can simplify the product of radicals that have the same index. Let's take a look at a couple of examples here. So if we have the square root of 16 times the square root of 9, the square root of 16 is 4, the square root of 9 is 3, so I can say 4 times 3 is 12. I can do it that way, or I can look at it and say, oh, the square root of 16 times 9, I can multiply the square root of 16 times 9 together and get the square root of 144, which is also 12. So you can simplify first and then multiply, or you can multiply and then simplify. You should still get the same answer. Okay? So in other words, the square root of 16 times the square root of 9 is the same thing as the square root of 16 times 9. Same thing happens with cube roots. If I have the cube root of -8 times the cube root of 27, the cube root of -8 should be -2. Oops, I missed the negative sign in there. Okay, so this should be -2. And, okay, so we've got -2 times 3, which is -6. And the cube root of -8 times 27 is the cube root of -216, which is also -6. So again, you can simplify first and then multiply, or you can multiply and then simplify. Basically, that leads us to the combining radical expressions rule, okay, which basically says this. The product of the principal nth root of two numbers equals the principal nth root of their products. In other words, you can multiply first and then simplify, or you can simplify first and then multiply. The nth root of a times the nth root of b is the same thing as saying the nth root of a times b. Now, that being said, if we want to multiply, okay, we should look to see if we can simplify first, because it actually is a lot easier to simplify it first. Okay? Could we multiply these particular roots? Can I multiply the 4th root of 7 times the 5th root of 7? Well, the index numbers are not the same, so no, I cannot. If this is a 4th root and this is a 5th root, these cannot be multiplied. Okay? Or simplified in this case. Can't be simplified because the index numbers are not the same. Not the same index. How about, can I simplify the 5th root of -5 and the 5th root of -2? Yes, I can. Okay? Because they both have 5th roots. So I can simplify this to the 5th root of 10. Because -5 times -2 is positive 10. If the radicand of the nth root of a has a perfect nth power among its factors, you can reduce the radical. If you reduce a radical as much as possible, the radical is said to be in simplest form. Okay, this is really important because if they ask you to simplify something in simplest form, it has to go down as far as it possibly can. So, what is the simplest form of the cube root of 135x to the 5th? Okay, well, I know 135 can be divided by 5, so I'm going to say that this is 5 times 27. Okay. I also know that 27 is 3 times 9, and 9 is 3 times 3. So number-wise, I can take out a 3. I have to leave the 5, because you have to have groups of 3 to take anything out. Variable-wise, remember, I have x to the 5th, so I'm going to take 5 divided by 3, and I'm going to get 1 remainder 2, right? I have, okay, 3 goes into 5 one time with a remainder of 2, which means 1 of my x's can come out, 2 of my x's have to stay in. Okay, so I have 3x, it's an odd root, so I don't have to worry about the absolute value symbol, 3x cube root, don't forget this index, of 5r squared, or 5x squared, because I had a remainder of 2. Now, very, 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 very important. Neatness. When you're working with radicals, neatness is critical. Because if I wrote this, is that the cube root, or is that x to the cube and that's the square root? I can't tell. And if I can't tell, I'm going to mark it wrong. Make sure it's clear what is a power and what is a root for a radical. Make it clear. This should be 3x cubed roots of 5x squared. And also make it clear that your root goes all the way over the x squared. Okay, I prefer if you take something out of the radical, you put it in the front rather than behind, so it doesn't look like it's still underneath the radical. Neatness counts in this chapter. Very important. Now let's look at the cube root of 128x to the 7th. All right, 128, that's 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. I'm looking for groups of 3. Okay, 1, 2, 3, there's one root, 1, 2, 3, there's another root. This guy gets left behind. So I can take out 2 times a 2. Okay, variable-wise, I have x to the 7th. So that's going to be 7 divided by 3. 3 goes into 7 2 times with a remainder of 1. So I can take out 2 x's, x squared. But I leave 1, 2, and 1 x behind. Right? So basically what I have here is 4x squared cube roots. I left a 2 behind and I left an x behind of 2x. Notice, because it's an odd root, we don't need absolute value symbols. Even if it was an even root, we still wouldn't need absolute value symbols because we took an even numbered variable out of an odd numbered root. Okay? The more you do these, the better you get at them. Okay? And of course, even if your calculator can do it for you, I'm going to make you do it by yourself. And there are specific scientific calculators that can do this, so I'm going to make sure that you just basically have a basic calculator that adds, subtracts, multiplies, and divides. And make sure there's not a calculator that you can use to make this easier for you, because I want you to learn how to do it. All right, simplifying a product. Okay. So if I have a product here and I want to simplify these, you can choose to multiply them first and then simplify them, or you can simplify them and then multiply them. This is what I do. I look at this and I say, well, can I simplify it to begin with? Well, do I have the same index numbers? I've got a 3 here and a 3 here, so yes, I have the same index numbers, so I can simplify these. That's the first thing you should always look for. Okay. Now that I've done that, I know I'm looking for the cube root of 25x y to the 8th times 5x to the 4th y to the 3rd. Okay, so I'm just going to make this easy on myself. That's the cube root. 25 is 5 times 5, and I still have this other 5. So I have 3 5s, 2 of them coming here, 1 of them coming from there. X to the 5th, y to the 11th, because when you multiply powers, you add the exponents. So that's what I'm looking for. I'm looking for groups of 3 out of this. Well, obviously, I can take a 5 out of it. Okay? I can take a 5 out. If I take x to the 5th, okay, x to the 5th is 5 divided by 3, which is 1 remainder 2. So I can take out 1x, 2 get left over. Y to the 11th is 11 divided by 3, which is 3 remainder 2. Okay, so 3 y's can come out, 2 y's get left under. So there are no numbers that get left under, so that's a cube root. But I do have an x to the 2nd and a y to the 2nd. Or, yeah, x to the 2nd, y to the 2nd. So we have 5x, y to the 3rd, cube roots of x squared, y squared. Let's look at number 6. Now, if you look at number 6, we have numbers on the outside as well, so don't forget that those are already there, and we need to take care of those. Okay, so I basically have 7 times 5, okay, 4th roots of 12 times 108. Okay, so I'm going to break down 12. 3 times 4, 4 is 2 times 2. 108, let's just do 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. I'm looking for groups of 4. Okay, groups of 4. I'm going to do this in a different color so you can see it. There's one group of 4. Okay, Here's my other root of 4. So I can take out 1, 3, and 1, 2 into the 7 and the 5 I already had. So I had a 7, and I had a 5, and now I have a 3, and now I have a 2. So I need to multiply 7 times 5 times 3 times 2. So I get 210. So the fourth root of 12, excuse me, 5 fourth roots of 12 times 7 fourth roots of 108 is 410. Now, since we define division in terms of multiplication, okay, you can extend the property for multiplying radical expressions to division. If the indexes are the same, you can write a quotient of roots as a root of a quotient. So in other words, the nth root of a divided by the nth root of b is the same thing as saying the nth root of a divided by b. Now, to divide radical expressions with the same index, you divide the radicands. Okay, so let's take a look at a few of these. Okay, so I have the cube root of negative 81 and the cube root of 3. Neither one of those are perfect cubes. So, okay, I'm going to look at this and say, okay, I can separate. These are separated. I can put them together. The cube root of negative 81 over 3. Now I can take 81 and divide it by 3. That becomes the cube root of negative 27. And I know the cube root of negative 27 is negative 3. You should know some of your basic cube roots. Number 2, we have this fourth root of 16 over the fourth root of x to the fourth. I don't need to put this together because I can just simplify it. I look at this and say, oh, the fourth root of 16. 16 is 4 times 4, and 4 is 2 times 2, so the fourth root of 16 is 2. And if I have x to the fourth, that's going to be 4 divided by 4, which is 1. Since I'm taking an odd number out of an even root, I need the absolute value symbol. Forget that. Okay, so it's 2 over the absolute value of x. Number 3. Now, okay, if we look at number 3 here, I'm looking at this going, 232 and 243. Those may actually simplify by themselves. I think 32 does. I'm not sure about 243, and I'm going to actually have to do it. It's a fifth root. So I know my a's and b's can come out because they're to the fifth power. So I'm just going to look at my numbers because I know I'm going to have an a on the top, and I know I'm going to have a b on the bottom. Okay, so I'm just going to look at my numbers 32 and 243. Okay, 32, I already know that's 2 to the 5th. Okay, it's 2 times 16, and that's 2 times 8, and that's 2 times 4, and that's 2 times 2. So there are 1, 2, 3, 4, 5 of them. Okay, so I know I can take a 2 out of this. Okay. 343, I know that's divisible by 3 because 4 plus 3 is 7, plus 2 is 9. My notes division by 3. That's 3 times 81. And 81 is 9 times 9, and 9 is 3 times 3. So I have 5 3s. So I can take out the 3. I don't need to worry about the absolute values on my variables because my variables it's an odd index number. So I'm not taking an odd out of an even, I'm taking an odd out of an odd, so it doesn't matter. Okay, so the fifth root of 32a to the fifth over the fifth root of 243b to the fifth is 2a over 3b. Now they don't all simplify really nicely like that. Because sometimes, if you remember with square roots, when calculating with radicals, the radical is not simplified until there are no radicals in the denominator. Okay, back in this last page over here, these bottom problems, there are no radicals in the denominator anymore. There's absolute value symbols, but there's no square roots or cube roots or fifth roots. Okay? If you have a radical in the denominator, you have to rationalize the denominator. We've done this before. Okay, we did it with, remember, we did it with imaginary numbers too. You had to multiply by a conjugate to get rid of the absolute value. Here you have to look at the root that you're looking for to get rid of your root. Okay, to make sure you don't have any extra roots. So if I've got the square root of x to the third over 5xy, the first thing I'm going to do is I'm going to simplify this as much as I can. Okay, I know I have 3 x's up here and 1 x up here, down here, so I know one of those can go away. So this becomes the square root of x squared over 5y. None of that simplifies. Therefore, I'm going to make this the square root of x squared divided by the square root of 5y. Since it's a square root, to get rid of the square root of 5y, I just need to multiply by a fancy form of the number 1, which is how you rationalize the denominator. So I'm going to multiply by the square root of 5y over the square root of 5y, because remember, that's just multiplying by 1. So on the top, I will get, since they're both index numbers are 2, I can multiply them together. I get the square root of 5x squared y. On the bottom, I get 5y. But you have to remember, okay, that we have to remember that we cannot simplify outside and inside, because I get a lot of people who will look at this and go, oh, this y out here will cancel with this y in here. No, well, one's inside and one's outside. You can't cancel. You're done at this point in time. Okay? And since I was multiplying, okay, the square root of 5y times the square root of 5y is 5y. Okay? Should we have the absolute value symbol on the y? Most likely, yes. Okay, so make sure you put that absolute value symbol there. Okay, because we took an odd number of variables, one y, out of an even number group. Okay, so don't forget that as well. Now that's easy because we've done square roots before. Okay, cube roots, fourth roots, these are a bit more complicated because I'm not going to multiply by just the square root of something because you can't multiply a cube root by a square root. So the first thing I'm going to do here on problem number 2 is I'm going to simplify this because I know 4 30-seconds reduces. Okay, 4 goes with itself once, and it goes with 32 8 times. So now I have, and I'm going to do this in a different color so it's not so confusing for the problem before it. I have the cube root of x to the 4th over 8yz to the 3rd. Okay, so I'm going to simplify this as best I can. So I'm going to separate it. So I have the cube root of x to the 4th over the cube root of 8y z to the 3rd. Okay. Now, before I start thinking about getting rid of that cube root of 8yz to the 3rd on the bottom, I'm going to simplify it if possible. I know the cube root of 8 is 2, and I can take out the z. So I now have the cube root of x to the 4th on the top. On the bottom, I have a 2 and a z on the bottom, cube roots of y. Okay. So what I have to get rid of is just the cube root of y. Now, if I multiply by the cube root of y over the cube root of y, I would not get rid of the y. Okay, pay attention to this. This is really, really important. So, because you might look at this and say, excuse this a second. Okay, back to this. If I multiply the cube root of y times the cube root of y, I only have the cube root of y squared. I didn't get rid of my cube root, did I? In order to get rid of my cube root, I'm going to have 3 cube roots of y. Okay, because then if I multiply this by the cube root of y, I then have y. So, look at this. I have 1 y. I need 3 to make it go away. So therefore, what I'm going to multiply by is the cube root of y quantity squared. Okay. I have to do the same thing on the top as I do on the bottom. So now I have, okay, on the top, I'm going to have the cube root of x to the 4th, which I can simplify. I don't know why I didn't simplify that sooner, but I'll simplify that in a minute. Okay, x to the 4th, y to the 2nd, right? All over 2z y, or yz, I should put it in alphabetical order. Because now I have 3 cube roots of y, so they come out. So now I just need to simplify that top because I have that x to the 4th here. So I should simplify that. So x to the 4th becomes x cube roots of xy squared over 2xy. And we do not need any absolute value symbols because, yz. Why did I put an x in there? It's only me. Do this all the time. Okay, 2yz. Sorry about that. We do not need any absolute value symbols because while working with an odd root. There's a lot of work to this. When you have powers higher than square roots, it's a little harder to rationalize your denominator. It takes a little bit more work. So it's really important that you pay attention. Let's do another one. We have 1 over the 4th root of 2x. Okay? This one's a little bit simpler in that there's nothing really in the numerator, and in the denominator we have the 4th root of 2x. Okay? I need 4 of them to be total. I have 1, so how many do I have left? If I need 4 and I have 1, I need 3 more. So I'm going to multiply by the 4th root of 2x quantity cubed. Okay? So on the top, I will get, okay, the 4th root of 2 cubed x cubed, I just distributed that cube, over the 4th root of 2 to the 4th x to the 4th. Okay, which means what happens to the 4th root of 2 to the 4th x to the 4th? The 2 goes, the 2 to the 4th comes out, so the 2 comes out and the x comes out. So in the bottom I'm going to have 2, but an absolute value of x because I took an odd number of variables out of an even number root. And on the top, okay, I have 2 to the 3rd, which is 8, so I have the 4th root of 8 x to the 3rd. So that one was a little easier. And that one's a little easier to do. I'm going to do the 4th problem underneath this problem over here so that you can see a little bit better. Okay, so problem number 4, which I'll do in red, said the 4th root of the cube root of 4 divided by the cube root of 6x. Okay. And I'm going to do this like most people would do it. I'm going to look at this and go, oh, I've got cube root of 6x. I need 3 of them. I have 1 of them, so I need 2 more of them. So I'm going to multiply by the cube root of 6x, but I have to square that. Okay, so I'm going to do the cube root of 6x, but I have to square it, so I have a total of 3 on the bottom. So my denominator becomes 6x. My numerator becomes the cube root of 4 times 6 times 6 times x times x. I'm just leaving it like that because I'm going to simplify it. Okay? Because, now if I look at this, 4 is 2 times 2, 6 is 2 times 3. Okay? I need cube roots of these things, so I need 3 things to take out 1. Okay? So I have 3 cubes I can take out, and that's it. Okay? So I can take out a 2. Right here. 2 cube roots of 3 times 3 is 9 times 2 is 18. Right? Because it's right, so we're going to have 18 x squared all over 6x. And you might say, oh, I'm done. And you're not. Okay? Because, remember what I said, we cannot simplify if one thing is under the radical and the other thing is outside the radical, but you can simplify if they're both outside the radical. So I can simplify that. Okay, so now I have, last but not least, the cube root of 18x squared over 3x, because 2 divides into 6 3 times. So there's my final answer. Okay. And that would be rationalizing your denominator. Rationalizing your denominator when it's an index of higher than 2 is a bit more tricky. So it does take a little finesse.